Hello bachcho and welcome. Today we are going to tackle a very simple but super important topic from our first unit, electric charges and fields, and that is conductors and insulators. Now don't worry at all, we're going to break it down so simply you'll remember it forever and it will be completely safe for your exams.
Okay, so to get started, let's dive into a little puzzle, something you've probably seen happen in your own home, maybe you've even tried it yourself. So have you ever actually wondered about this? You take a plastic comb, rub it on your dry hair, and poof, it magically starts picking up tiny bits of paper. But then you try the exact same thing with a metal spoon, and nothing happens. Why? What's going on here? The answer to this is exactly what we are here to learn today. You know, the entire secret, the whole difference between that comb and that spoon, it all comes down to these tiny little particles called electrons, and, more importantly, how much freedom they have to move around inside the material. Now, to make this idea crystal clear in your mind, let's use a very simple analogy. Just imagine that every material, whether it's plastic, metal, or wood, is like a big building, and the electrons are the people living inside that building. Trust me, this little mental picture is going to make everything click. So look at this. A conductor, like our metal spoon, is kind of like a big open hotel lobby. The people inside, who are our electrons, remember, they can walk around freely, go anywhere they want. There are no restrictions. But an insulator, like our plastic comb, that's a whole different story. It's like a cinema hall. Everyone has an assigned seat and they are stuck there. They can't just get up and roam around. The electrons are bound to their atoms. This right here is the main difference. Okay, so the lobby and cinema hall analogy is fantastic for understanding the concept, but what do you need to write in your board exams to get those full marks? For that, we have to look at the official definition from your book. Now, this is word for word from your NCERT textbook, so pay close attention. It says, those which allow electricity to pass through them easily are called conductors, and the key reason it gives is that they have electric charges, electrons, that are comparatively free to move. See? Just like our lobby. On the other hand, materials that offer high resistance, they are called insulators. This is the exact language you should use in your answer. So, to boil it all down, what are the key words you must remember? For conductors, the magic words are free electrons. They're like a smooth, open highway for charge to travel. For insulators, the key phrase is tightly bound electrons. They're like a blocked road, a dead end for charge. It's that simple, right? Perfect. Now that we have the theory sorted, let's go back to our original mystery, the comb and the spoon. Let's solve it once and for all using what we just learned.
Okay, so here's the step-by-step breakdown. When you rub the plastic comb, an insulator, the charge that gets transferred to it gets stuck. It's trapped in that one spot because the electrons are not free to move. This little patch of localized charge is what attracts the paper. But, and this is the aha moment, when you rub the metal spoon, which is a conductor, the charge is totally free to move. It doesn't stay on the spoon for even a millisecond. It instantly spreads out and flows through the spoon, into your hand, down your body, and into the earth. Why? Because you, your body, and the earth itself are also conductors.
So basically, the charge on the metal spoon just leaks away. It finds this massive, easy escape route through us, all the way to the ground. This is a very important concept called earthing, or grounding, which we will study in more detail later. But for now, just remember the spoon simply cannot hold on to that extra charge. All right, let's quickly talk about some very common mistakes that students often make. I like to call these silent killers, because they can quietly cause you to lose marks in your exam, even when you think you've understood everything. Let's make sure this doesn't happen to you. The first myth is that insulators have no electrons. This is completely wrong. They have billions and billions of electrons, just like conductors do. The only difference, as we learned, is that their electrons are tightly bound, stuck in their seats. The second myth is that conductors somehow create new charge. No, they don't. The charge is already there, in the form of these free electrons. Conductors just provide a convenient path for these existing charges to move easily. So, let's do a quick recap of everything we learned and also see why this simple idea is so fundamental for the topics that are coming up next in your syllabus. Here is your quick revision summary for your exam notes. Conductors, they have free electrons so charge can flow easily. Insulators, they have tightly bound electrons so any charge stays put. And remember the examples. Metals, the human body, and the earth are all good conductors. Plastic, wood, glass, and rubber are common insulators. That's it.
And why did we spend so much time on this? Well, because you simply cannot understand electric current without knowing what a conductor is. Where would the current flow? And you can't understand how a capacitor stores charge without understanding both conductors and insulators. This concept is the absolute foundation for almost everything else in electrostatics.
And to finish, I'm going to leave you with a little question to think about. We just established that if you hold a conductor, like a metal sphere, and you try to charge it, the charge will just flow away through your body, right? So, how do scientists in labs manage to put charge on a metal sphere and actually make it stay there? What's the trick? Think about that, and we'll explore the answer in our next experiment.